Okay, here we have a question that says, which relationship can be described as causal? That means that, of course, causal, referring to the word cause, this means which of the relationships here imply that one of the things causes the other, right? That's what a causal relationship is. So in the first case, does height cause your intelligence, or does intelligence cause your height? In other words, does it mean that the taller you are, the smarter you are? And the smarter you are, the taller you are? Well, the answer, of course, is no. Next, we have shoe size and running speed. Well, here, I mean, if you have a really, 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 really large foot, does that mean you can run really fast? Absolutely not. And vice versa, if you have a really, really, really small foot, does that mean you run slow? No, of course not. So that doesn't matter. Number of correct answers on a test and your test score. Yes, that should be causal, right? The more answers you get correct, the higher your score, or the lower the lower amount of answers you get correct, or the less amount of answers you get correct, you have a lower test score. So that's a causal relationship. But let's look at number 4. Number of students in a class and number of students with brown hair. Well, that there might be a correlation there. There might be a lot of students in your class, and they all might have brown hair. However, just having students in your class doesn't mean that they will automatically have brown hair. Next question. Erica is conducting a survey about the proposed increase in the sports budget in the hometown school district. Which survey method would likely contain the most bias? In other words, which of these survey techniques will give you the least reliable result, or will only represent the smallest group? Right? Again, with surveying, the idea is that you have to survey, this group of people, all these people to survey, and you want to represent all of the people with the smallest amount of surveys, right? You don't want to have to go out and ask everybody the question, but your small group should try and represent everybody. So this first one's pretty good, right? You ask every third person entering the hometown grocery store, except the people entering the grocery store, depending on what time of day you go or what types of grocery items the store sells, will, of course, only represent certain people, right? If the items are very expensive, only the very wealthy will shop there. But however, this is not that bad because they're going every third person, and it's just a grocery store after all. So it is biased, but it doesn't seem so terrible to me. The next one, Erica asks every third person, another good random technique, leaving the hometown shopping mall. So again, there is some bias there. Who is shopping at the shopping mall? People with enough money to go shopping. The people that can't afford shopping won't be there, and you'll never know how they feel about it. Or the people who are, in general, especially if it's about a proposed increase in the budget, that means you would be asking people who have the money to shop about asking for more money in the school district. But what about the people who can't afford to go shopping? How will they feel about the proposed increase in budget? Right? They won't feel very good about that, but you're not really going to get them if you're only serving people who are going shopping. Okay, you ask every fifth student entering the hometown high school on Monday morning. Well, that is really biased because you're only going to be getting students, not even teachers or parents, only the students in this case, who probably aren't going to be voting on the budget. Last, we have Erica asked every fifth person leading Saturday's hometown high school football game. Okay, so this one as well is pretty biased, right? Because you're asking only people going to the high school football game, people with school spirit, right? I guess if they're there for the game, they're related to the school and the activities, and then they know that the budget will affect your football team or whatever. Those people will be most likely probably to support a budget increase. So that's your most biased right there, because again, the people going to the football game, um, of course, are supporting the school, and I mean the students are also biased here because they go to the school and they'll want their school to be supported. However, maybe not every student really cares about having a budget increase. But I would guess that everybody leaving the Saturday hometown high school football game will be a part of the community and therefore really want to have the budget increased. So I would say 4 is probably most biased, although you could argue that 3 is also extremely biased as well. So I wouldn't do this often, but I'm going to circle both. I don't think there is a definite answer here. You can really argue either one. Okay, next. A survey is being conducted to determine which types of television programs people watch. Which survey and location combination would likely contain the most biased? Same type of question where we're trying to find the most biased. So usually the smallest group is the worst, right? Because they'll represent the smallest amount of people. Um, Here, and if you're only asking 10 people who work in a sporting goods store what they want to watch, they're really going to probably say things that relate to the theme of the store that they're working in. That's going to be extremely biased. 25 people entering a grocery store, it's a larger sample size, it's less biased, and they're at a grocery store, so they're shopping for all types of items, right? Many people shop of different walks of life, all shop at the same grocery store, so that's certainly less biased than the first one. 50 people, even more people, um, and they're in the mall. Well, lots of people are able to go shopping. Of course, people who can't afford to go shopping won't be there, but that's less biased, I think, than the sporting goods store. Randomly surveying 75 people during the day in a clothing store. Well, again, all people need clothes, so of course, only people with money will be shopping there, but that'll be more random than the first survey sampling. So I think 10 is the most biased. Also, notice they don't even use the word random in the first two choices, they only use it in the second two. Okay. Okay, so in this problem, there's a person playing in 10 baseball games this year, and he had hit the ball these many times in each game 2, 3, 0, 1, 3, 2, 4, 0, 2, and 3 times. In the first 10 games he plays next year, he wants to increase his average hits per game by a half. What the total number of hits Johns needs over the first 10 games next year to achieve this goal? So what did he hit this year? Let's find that out. Let's add 2 plus 3 plus, right, all this stuff up here. This is from this year. Let's add up these numbers. So, and I'm going to put them over here. So we have 2 plus 3 plus 1. I'm going to ignore the 0. Plus 3 plus 2 plus 4 plus, ignore the other 0. 2 plus 3. That's this year. So this year he had 20 hits. So if we add all those up, we get 20. So his average would be 20 divided by 10. So 20 divided by 10. To average those out, we take 20 and divide it by the number of at-bats, right? And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 at-bats. So that's 2 hits per game. But this year he wants 2.5 hits per game. So think about this algebraically. He has to get an average of 2.5. So 20 hits plus what number, when you divide up by 10, will give you this average. So now we just solve for x. We're going to multiply both sides by 10. So to do that, we get 20 plus x over 10 times 10 on both sides, 2.5 times 10. These cancel out. And 20 plus x equals 25. Subtract 20 from both sides. And what? Well, x equals 5. So that means he'll have to hit 5 more hits this upcoming year to get the new average of 2.5. Alright. Which scatter plot shows the relationship between x and y if x represents a student's score on a test and y represents the number of incorrect answers. So the more answers you get incorrect, the lower your score. So the incorrect answers here on test scores don't really make sense because this is saying the more incorrect answers, the higher your test score. That's not usually going to happen. Here, it doesn't really seem to matter, right? There's no real line of best fit here. Maybe it's kind of here, the line of best fit. That kind of implies that it doesn't really matter how many things you get wrong. Your test score can still increase, right? Because as you go further on the x-axis, your test scores are increasing. The fourth choice doesn't make sense as well. This is saying that no matter how many incorrect answers you have and go up on the y-axis, your test score is always the same. Whatever your test score is, it's always this one number. So the only thing left is this choice right here, and that makes the most sense because, right, your test scores are going to do what? Well, as the number of incorrect answers is increasing, as the number of incorrect answers is decreasing, the test score is increasing, right? This is a low test score right here with a really high amount of incorrect answers. Jump on this side, this is a really high test score with a really low amount of answers. And the trend is, this is going down here. That means, yeah, your test scores are going up along the x-axis as your height is going down, as your number of incorrect answers are going down. So that one is the answer. Brianna's score on the National Math Assessment exceeded the scores of 95,000 of 125,000 students who took the assessment. What was her percentile rank? So here, it's not clear which approach they want us to take, but we'll say if you exceeded 95,000 out of 125,000, right? Then what does that mean? Well, that means that if we set this up, it's 95,000 divided by 125,000, right? You get 0.76. This means that 76%, 0.76 is 76%, right? Because 0.76 times 100 equals 76, and that's 76%. So here, 76% of the population didn't do as well as her, and that's what percentile rank means. It means where are you in the line of in the grand scheme of things, I guess. So this is all the people who took the test, and we're saying that well you're here, and 76% of the people did not do as good as you. Excuse me. That means you're at the 76th percentile rank here. So it's your percentile rank is the level that everyone else is below, right? So if you're at 76th percentile, that means you beat 76% of the people. Okay, which statement is true about this data set? 3, 4, 5, 6, 7, 7, 10. Okay, so I know this is not really necessary, but I'm going to enter this on a calculator so that you get familiar with that. I go to my stat button. I'm going to enter this into a list, so hit enter. Here I'm going to clear off list 1, scroll up here, press clear and enter, and then enter these data points in. 3, 4, 5, 6, 7, 7, and 10. Okay, so our list 1 is complete. Let's quit here. So let's find the mean, and let's find the median. The mode is just 7, or you can see that number being repeated there. The mode is the thing that appears the most. So now we're going to find the mean and median. So we go to second stat, and here's our math icon. Scroll over to the right. See choice 3 is mean. So I want to find the mean of that list we just made, which is list 1. Hit second 1, and the mean is 6. So I'll write that one down. The mean equals 6. Next, let's find the median. Second stat, math, median. Oops, sorry. Second stat, median. I should enter the list. Second 1 for list 1, and the median is 6. And again, the mode is 7. Oops, mode is 7. So the mean equals the median, which is choice 3, and that's the only correct one because the mean is not less than the median, the mean is not greater than the mode. In fact, the mode is greater than the mean, and the mean and mode are not equal. All right, hope this helped.